Howdy, y'all. So today we're joined by Dr. Sarah Powell and Dr. Amanda Vanderheyden. Dr. Sarah Powell, would you like to introduce yourself first?
Yeah, thanks, Corey. Hi, I'm Sarah Powell. I'm an associate professor at the University of Texas at Austin, and I've been there for 9 years. And before that, I started my educational career as a kindergarten teacher and then spent a lot of time in elementary and middle school classrooms thinking about how students best learn math. And so those are some of the things I'm excited to share with you all today.
Dr. Amanda Vanderheyden, would you like to go next?
Yeah, hi, my name's Amanda Vanderheyden, and I am a founder of Spring Math and have been mostly conducting research for most of my career in multi-tiered systems of support and RTI around especially improving math achievement in school systems. So we do have a website. I'm sure that's going to come up during this conversation, but not just Sarah and me and Corey, but everybody else. You can go to this website and see the people who are beginning to contribute, and we hope people will join us. You can reach their bios right through the contributors link.
Great. So the first question, I'm going to throw it to you, Amanda, is was there a catalyst that kind of propelled you to want to begin to create the science of math movement?
Well, yes, and it's from people, right? Reaching out to me, reaching out to my colleagues, and asking questions like, how is this tactic like, or this idea that timed assessment is bad for kids? Where did this come from? Like, who is spreading this misinformation, right? So, it's easy as a researcher to kind of have your head down and work on what you're working on and not really pay attention to the bigger world. But then when you go out into the bigger world to train teachers, to advise states, this happened to me when I went out to work with the state on math achievement, and I ran into what Robin Cotting and I call modern math myths, right? And they were actually thematic. So there were these things that kept coming up that teachers really believed. And for me, it felt like it really robbed space for more effective practices, right? And we would spend half the training trying to explain to teachers that what they really believe is not evidence-based. And so this just became apparent to me that people like me and Sarah and you and others who are trying to really do good evidence-based work are not doing an adequate job disseminating our findings. And the people who are disseminating advice about how to teach math don't necessarily feel constrained by evidence. They don't feel that they must follow the science of math. And so, of course, the science of reading movement has been underway. And people, it's an advocacy driven movement that says every child should have the right to highly effective reading intervention and instruction. We believe that for math. And so people began to reach out to me and some of you I know saying, hey, you guys, I see your tweets. I see that you're, speaking out about evidence-based practices in math. When is the science of math going to happen? And so several of us just began to have conversations, and then we began to meet, and now here we are with our initial launch with a great group that is designed to be inclusive, and we really want people to join us in this movement.
Yeah, Amanda, it kind of sounds like a lot of the teachers were probably really frustrated with not being trained adequately or receiving adequate professional development in the science of how to teach math well. And so I guess part of this movement is for you to help disseminate information with the team.
Yeah, and parents, right?
Yeah.
So parents are saying, what happened? How come my child is coming home with these strategies that you're on Twitter saying don't work, right?
Yeah.
Yeah.
Well, and I think a lot of parents and caregivers just really want to know what can they do to help their child. I've talked to a lot of caregivers where their student has just been identified with a learning disability in math, and they say, where do I turn to for resources? And as you said, Amanda, a lot of people are like, oh, I can go to the science of reading and that's what I should be doing in reading. And so that's why I think we all felt that it was time for the science of math to help not only teachers but also caregivers really understand what should they be doing when their child is experiencing some math difficulty.
Yeah, this will be a win if we can crowdsource science, right?
Exactly.
Doesn't
I
have to be
agree.
my tool, doesn't have to be your tool, Pirate Quest. I love your tool. I mean, it doesn't have to be our stuff, but I want them to use things that can work because every child deserves that opportunity. And in math, I've heard Anna Stoke describes it as relentlessly hierarchical. I think that's a beautiful way to think about math. The point is, if you miss it in the early years, you are in trouble. You are forever blocked from the advanced opportunities. And so that's educational malpractice.
Yeah. And getting to that idea that I know our group and many others have talked about is that this is really an equity issue, is that all students have the right to a very strong math education, and they can look to the science of math for some ideas to how to get that started.
Yeah, great. So, Dr. Powell, I'm going to ask the next question to you. What is the science of math? Can you give us a definition for that, along with what you believe its core missions are?
Great, great question, Corey. So, we thought a lot about what would be a definition of the science of math. And so we came up with a definition that we feel this is a movement where we are focused on looking at objective evidence about how students learn and how students learn math. And we can take that evidence to then make educational decisions that can inform what goes on in the classroom, as well as what goes on in the policy world. Is that a pretty good definition there, Corey?
Yeah, that's really great. And so, Amanda, I don't know if you want to piggyback off of that, but uh, why should we value scientific research to guide instruction rather than just gut instinct?
Well, gut instinct is tantamount to unconsented experimentation on children, and the stakes are high. I mean, there's a great Kuhn and Davis article in 2019. It was a well-funded IES study that demonstrated that it really didn't matter if children enrolled in advanced course sequences in math in high school versus even remedial track sequences in high school math in terms of their likelihood of meeting the ACT benchmark, readiness benchmark for college math. Kind of shocking, right? After you controlled for what they could do in terms of fifth grade math performance. So I think this is that's that math is relentlessly hierarchical. And I think it's easy, like when you're running a marathon and your miles are too slow at the beginning, you'll never correct for it later. And that's happening all over the country in math education. So teachers come out of their training programs, and just like in the science of reading, there are great studies that show us that teachers actually are not equipped in the science of reading. And we know learning disabilities in reading are largely preventable. I mean, that's a wonderful finding in my lifetime that should be absolutely celebrated. But it depends upon early detection and highly effective early intervention. And in math, that parallel is absolutely true. So what we need to be about is making sure that parents are equipped to ask for the right things. Leaders are equipped to vet tools with the right, framework. And teachers are equipped to teach every child how to attain mathematical mastery on the fundamentals. It's a basic equity right, just like Sarah said at the beginning. I really believe that.
Yeah,
And
I'd
one of
love
the
to put it.
things, oh, go
Oh,
ahead,
go
Corey.
ahead. Oh, well, I was going to say there's a great study conducted by some Texas A&M colleagues. I think Emily Binks Cantrell led it, and it's called the Peter Effect. You can't give what you don't have, and basically demonstrating some of the challenges we have in teacher preparation. And a lot of our issues start there, where teachers are
Mhm.
graduating without being adequately prepared to provide high quality, scientifically based instruction.
Yeah, and I really think there is a science of instruction, period.
Oh, there
It's,
is.
it's
Yeah.
content theoretical, right? So we all talk about this and we all write about it. Like, for example, the instructional hierarchy, that every teacher is not equipped coming out of their preparation programs to deeply understand how to put that to use in their classroom to get better learning is astounding. It's astounding. It was first written about in 1978. It is the basis for everything I do in multi-tiered systems of support to improve core, to improve intensive, deliver truly intensified instruction. So it's just remarkable to me that we are not able, part of what we all need to be doing as researchers is delivering on a faster time frame from discovery to well led implementation in systems. So, I think sometimes people can think, okay, the science of reading and the science of math is about being an expert in reading or an expert in math content. And that's not the case. It's really about being an expert in the science of instruction, which includes formative assessment and the instructional hierarchy and other things that we could talk about.
Well, and I think that ties in nicely, Amanda, to what I think about as the science of how people learn. And it's not just learn reading, but learn math. But if you're learning something new, there are some pretty standard ways that people learn things. And then that science of instruction ties in really nicely to that.
Yeah, and just to mention the site again, which I didn't give the address, it's just thescienceofmath.com. We cite Kirshner's great research and other people. That's a great point, Sarah. And so people can go to the site and you can find one-page briefs on common misconceptions. I'll call them myths. We call them misconceptions on the site, that you can read about and see, well, where does this come from? What does this really mean? And more importantly, what does the evidence actually say? And a lot of that comes from learning research, right?
Yeah.
Yeah, and it's so freeing, especially when you think about elementary school teachers or early childhood teachers or special education teachers, school psychologists. You might be tasked with teaching a whole host of content. It's not like, oh, I need to all of a sudden become an expert in all. It's like, well, no, people learn the same way, right?
Yeah.
And obviously there's a sufficient level of content knowledge we need in order to deliver instruction, but it's so freeing to know that the same types of protocols and instructional tactics are going to be efficacious across different areas.
Excellent point, Corey. I think you're exactly right there.
Yeah, we've talked about this, Corey, but it's like we talk about kids. Some kids are truly like teaching proof, meaning they're going to learn, almost know how sloppy the instruction is, but other children are teaching sensitive. So that the teaching has to be science-based. It has to be precise and powerful, or we're going to miss the window. We're going to miss the window to establish the correct understanding. So what we're about is helping teachers be equipped so that kids who are requiring really precise instruction in classrooms can get it. No matter what class they go to, they should be able to get it.
Well, one of the things when you were talking just a few minutes ago, Amanda, I think another reason evidence-based instruction is so important is because we don't have time to waste, especially for students that are experiencing difficulty in math, or perhaps they do have a learning disability in math. Like these students are facing challenges in math. And so we don't have 3, 6, 9, 12 months, or even 2 years to just say, hey, I like this idea. I'm going to try it out. We don't have the time to waste. And so the time is now. And if we want to really focus in on these students, we need to rely on those evidence-based practices. That's where we need to rely on the science.
It's a wonderful point. Yeah.
Dr. Sarah Powell, I'm going to send the last question to you. What do you see as the next steps that you'd like the science of math movement to tackle?
Well, I would say there's two important things. The first is that no movement is led by a few people. We need hundreds and thousands and tens of thousands of people to be talking about the science of math. There are nationwide conversations around the science of reading. When you go into most schools across the United States now, that term is common. We need to make the science of math as common as the science of reading. And anyone can do this. We need to have national level conversations, school level, person to person level conversations. Have you thought about the science of math? Have you visited this website? Have you been on their Facebook group? Have you joined the Twitter feed? Lots of conversations and lots of advocacy need to go on. And so I'd say the first thing is that we need to build this movement and keep adding to it. And I think that the second thing is also then keep going back and looking at the evidence. There's evidence coming out all the time. What are some of the new things that we're seeing that are really helpful for students in the area of math? We need to be putting those on the website and getting those out into the hands of teachers and caregivers and policymakers. And so I would ask people to be collecting data and sharing that data on things that are working in their classroom, because that can also contribute to the conversation related to the science of math.